Hello everyone. So today we are going to discuss the problem monism. This problem is very similar and follows the same idea that we did previously in coin combination 2. Coin combination 2. That is, we have to find the number of distinct ways to construct the sum to construct the monism. Right? We have given the coins. Now this problem. This is the 12th video from the DP series. Right? Now this problem is the very easy, right? If you are able to solve the coin combinations again, this problem you can solve by yourself, right? But still I discuss it. So let's go further. So you have n coins with a certain value, so your task is to find all minisums you can create using these coins, right? Now you have the coins n, that is n c1 c2 c3 c4 c5 up to cn, right? Now you have to construct the money. You have to construct the all money sum. That is all money sum. Right. So what is the maximum sum that you can create? What is the maximum sum that you can create? That is the sum of the all coins. Right. Beyond this, you cannot create. Right. So the maximum sum that I can create, the maximum sum that I can create is the sum of from I equals to 1 to n. See, this is the maximum sum that I can create. Right. Now try to think about the options that you have, right? And try to think about the ways that you have to try out, right? So there is something that if you can from 1 to maximum sum, you have to tell that by using these coins is you are able to create this sum. If yes, you maintain the corresponding flag, that is yes or no, right? And there is some number between this, suppose x, right? X maximum sum. So you can create x by using the sum by using these coins. If it is yes, you maintain a flag corresponding to this zero. If not, if yes, then corresponding flag is one. If not, the corresponding flag is zero, right? Perfect. Now what can you think about it, that you have the two ways that that you can take the coin, or you are not take the coin. Not take, that is we did in coin combination, that is pick or not pick, similar things. Pick or not pick, right? Is you are able to make the sum by not take, is you are able to make the sum by not pick. If one of them is true, that by not take you are able to construct the sum x, right? By pick you are not you are able to construct the sum x, right? That is, if you take, then you are able to construct. If you are not take, then you are able to construct. That is, if it is the case, then you are able to construct, right? When you are not able to construct, if both are zeros, right? If both are zeros, right? Now the thing is that what are the transition could I make by using these ways? That is the dp, right? That is if dp of ij, first let's understand what dp ij could represent, right? dp ij represents something, let's say dp ix, right? That by using the coins I, by using first I coins, can you construct the sum x, right? Can you construct construct the sum x or not? That is something what dpix represent. If dpix is equals to true, that means yes, you are able to construct. If dp of ix is equals to false, that you are not able to construct, right? By using first I coins, right? What the final problem that you are going to solve, that is n and the whole sum from 1 to maximum, right? 1 to maximum, that by using the n coins, are you able to construct the sum 1? If it is true, then you are going to print that sum, right? That sum, right? So you have to you have to uh, for all from 1 to maximum, right? You have to print the answer that you are able to construct or not. Now this so what by pick or not pick, how you are going to write your transition state. If you're not pick, that is dp of ij is equals to dp of I minus 1, that is j. That's if you're not going to pick, right? If you're not going to pick, that is j, the sum remains the same, right? The sum remains the same, sum remains the same, right? Now if you are going to pick, now first of all, when you are going to pick, when you are able to pick, when you are able to pick, if the coin I minus one, that the coin that you are going to take is less than equal to sum, then you're going to able to pick, right? If the coin that you're going to pick is greater than the sum, then what's the point to take it? It that never helps you to construct the sum, right? And if dp of I minus one, then you are going to look for, then you are going to look for j minus coins of I minus one, right? Next sum that you're going to construct is j minus, right? That is the left, or we can say that the remaining sum. If you're going to take remaining sum, so this is something that represent by using the first I minus coins. Are you able to construct the j minus coins, or coins of I minus one, that you are, if you are able to take, if you are going to take it, are you able to construct the sum, remaining sum? If it is yes, if it is yes, then definitely that dp of ij equals to true, right? Otherwise it is false. So you maintain the dp 2d array, right? You such that you maintain the 2d array, right? Such that the second thing that represent the value, the dp of ij represent by using the first I coins, can you construct the sum x or not, right? This is something what dp ij represent, right? So this is our transition state, right? Now what will be the base case? What will be the base case? That is, if you are, if you have to construct the sum of zero by using the zero coin, that is going to be true, right? That is going to be true, correct? So this is our base case. Now let's try to code it. I hope you understood the intuition. If it is not, let's comment it down. I try to help you. I try to resolve your doubt, resolve your doubts, right? Let's try to code it. Now let's try to code it. Let's try to code it. We have n number of coins. Let's take it as input. Define the vector coins of size n. If the input coins of y. Yes, this is the input. The next thing we have to do, that is we have to take the maximum. Now I use the function accumulate. That is coins dot begin coins dot and comma zero. This is the maximum sum, right? That I could create. Now next we have to define the dp vector. Vector of int. Now first is the coins, number of coins, right? The second is for sum, that is max sum plus one, and we initialize it with zero, that is false, that is false. Now this is correct, yes, perfect. Now the next thing we have to define the base case. What would be the base case? That is dp of 0 0 is equals to 1, that is the base case. Now next we have to go for all the coins I less than n, I less than equal to n, I plus plus, and for int j equals to 0, j less than equal to max sum, right? And j plus plus, right? We have to the first, the rows, the number of rows is n, right? And the columns are maximum, right? For all the coins we are going to fill, for that we are, if I'm at the coin 2, that what are the sums that I would create, right? That's how I fill, right? For example, suppose, let me show you, right? Right, suppose this is some row x, and this is some row x plus 1, right? Now for this row x, if you have the x coins, right? For x coins, are you able to create the sum that represents the sum 1? Are you able to create the sum 2? Are you able to create the sum 3, right? Are you able to create the sum 4 up to the maximum, right? Up to the maximum, right? So this is how you fill for, you fill for all the sum up till that coin, right? So up till coin 1, up till coin 2, up till coin 2, up till the coin n, right? And you have the operations that if you are not going to pick, that is dp of ij will be dp of I minus 1 and j, right? If you are going to pick, then when you are able to pick, if j is less than, one second, yes, if j is less, if coins, if the coin, let me take the coin, and coin is equals to coins of I minus 1, that is the coin. If coin is less than equals to, if coin is less than equal to the sum, right? if coin is less than equal to the sum, then I'm going to take it. And if that is true, what that is I minus 1. For the first I minus 1 coins, j minus coin. If it is true, that is gp of ij is equals to true, that I am able to construct that sum, right? Fill it with 1. Perfect. Yes, correct. Now what next should I do? The next thing, that for all this sum I have to create answer. Vector int answer, right? Now for int I is equals to 1, I less than equal to max sum I plus plus, and answer dot push back dp of ni when I am when I am able to dp of n I is equals to 1. Then I'm going to push it. Then I'm able to construct, right? What it means, that can I construct the sum I with the n number of coins? If it is true, that is my answer. That is, I'm construct that sum, right? So now let's print the for int I is equals to 0, I less than answer dot size I plus plus c out answer I, right? So this is something that I can write, right? I think this is this looks great. Let me check once. We find the maximum sum coins begins, right? We created the dp. We missed dp. Yes. Now dp of 001 1 to n j is equal to j plus plus. The coins equal int coin equals to coin I minus 1 dp by j dp by j. That's perfect. If coin is less than equals to j, and I'm able to construct that, then this will be true. Otherwise, it is false. Now I create the answer. If it is this. I think it looks great. Let's try to run it. Any other thing? No. Let's try to run it. Let's try to run it. Is there any mistake? Oh, it's print 111. That it. We have to push I. That is the sum. Right? Not the value of dp. Now let's try to run it again. Yes. Now it's gives us the correct answer. Right. So this is the code. I hope you understood it. The time complexity of this code is going to be n cross the max sum, right? And yeah, we're using the vector space of n plus 1 comma max plus 1 to the vector. Yes, it's correct. I hope you understood it. If it is not, comment it down. I try to resolve your doubts. Thank you.
Until we reach it, all you need to know is that we're holding